Hello everyone, welcome to the graph series of videos. So today we will see how to detect cycle in undirected graph. So finding a cycle in a graph is very much important and it is used in various problems. So now we will see how to detect a cycle in an undirected graph. Now the question is that how I told detect a cycle for undirected graph. Is it different from directed graph? Yes. If you see here, this is one undirected graph, and if we want to find the cycle here, so this is the cycle it is forming here, and I have two directed graph here. If you look at here, maybe they have a loop kind of scenario, but it is not actually forming a loop because their direction is in different way and they are not forming any loop. So that's why it is not a graph with a cycle. If you look at this directed graph here, if you see, they are forming a loop, okay, because of their edge position. So this is actually forming a cycle here. So that's why when you have to detect the cycle for directed graph and undirected graph, then the steps are actually a bit different. That's why in this video I am only discussing how to find the cycle in an undirected graph. So now we have to check how to detect a cycle for the undirected graph. So there are so many techniques. So one is BFS, one is DFS, or we can use topological sorting. So here we will use the BFS technique to find the cycle in a undirected graph. So for that purpose, we will make use of three terms. One is 0, that is not visited, 1 means visited, and 2 means processed. So initially all these nodes will be marked as 0 because they are not visited yet. Then whenever the current position will be there, that we can mark as visited, and then when we leave that particular node and move forward, then that node we can mark it as processed. So instead of 0, 1 and 2, you can make use of any numbers, -1, 0 or 1 also. Okay, so now suppose I am starting from this node. Okay, so as we are moving as a BFS technique, so for that purpose we need a queue data structure to maintain the nodes, and we'll follow these rules. Initially all nodes will be 0, then push all the adjacent nodes which are 0 to the queue, and we have to make them as 1, means visited. Then you have to pop from the queue and make those nodes as 0, 2, because that is processed. If adjacent nodes, when actually I am looking for any adjacent nodes to pick and push it to the queue, if that time it is already 1, that means cycle is there. So we will follow these rules and understand it better. So initially I will mark all the nodes as 0. So initially I have marked all the nodes as 0. Okay. Now as I am starting from here, I have to push this node into the queue. So 0 will be pushed in the queue. And the rule says as soon as you will push that element in the queue, then you have to mark them as 1. So now 0 will become 1. Now in the next step, what you have to do is we have to dequeue this element. So whenever we will dequeue that element, we will search for this element what are the adjacent nodes. So for this 0, the adjacent node is only one present, that is 1. So we have to push it to the queue, and we have to mark it as 1. And as 0 was dequeued, pop from the queue and make those nodes as 2. That means 0 is processed now. So I will mark it as 2. Now we have to, again in the second iteration, we have to check for the next dequeue element. So 1 will be dequeued and we will mark 1 as 2, and then we will check for the adjacent nodes for 1, that is 3. So we have to push 3 in the queue and mark the node 3 as 1. Now in next iteration I will pop 3 and mark it as 2, means processed, and then I will check for the adjacent nodes for 3, so that is 2 and 4. So in similar order, any order you can take here. So I will push 2 and 4 in the queue and mark them as 1, means it is visited. Now we have to pop 2 and I will mark 2 as 2 as it is processed. And for 2 I will check what are the adjacent nodes are present. So for 2 the adjacent nodes are 3 and 4. And whenever we are checking for adjacent nodes, we are checking if they are not visited, then only we will take them, right? So here we have not come up with an example. So that's why I'm telling. So whenever for 1 also we picked the adjacent nodes, that time we checked if this node is already 0 or not. If it is 0, then only we will insert it in the queue. So for 2, I have two options, like two adjacent nodes. One is 3 and one is 4. But 3 is already processed and 4 is visited. So here is the trick. So if we find any adjacent nodes which is already visited, that means definitely one loop is there. So for 2, when we went for finding the adjacent nodes, we got that this 4 node has already visited actually. So that's why there is a cycle present here. So this is the way we have to detect a cycle. If there is no cycle, then this kind of situation will never arise. So this is the technique to find cycle in a undirected graph. So here also, if you emphasize on point number 4, if adjacent node is already 1, then cycle is there. So this is the same thing we prove here. Now we will do the coding. So before proceeding to the programming, one thing to mention here is, so when I was marking this node as 0, 2 or 1, so actual operation we will do in an array. Okay, we will take one array as the same length of number of vertex or nodes, and in that array for that position we will update these numbers while traversing the graph. Okay, so we have to maintain one array to keep this record. Now coming to the programming part, here I have defined one class called detect cycle in undirected graph, and there I have defined this graph. Okay, so I have defined a static class which will hold one value called number of vertices v, then the adjacency list to represent the graph, and the constructor for this graph, and the add edge method, like where I can define like from which edge to which edge there is a connection present. So in the main method I have defined this graph with the initial node size as 5, because I will like create the problem with the graph which I have shown. And then I have defined the like edges, like from 0 to 1, one edge is there, from 0 to 2, from 1 to 0, 2 to 0, 2 to 3, in similar fashion. Then detect cycle one with like the I have initialized the object, and I am calling this method is cycle present. Okay, and whatever it will return, I will print that thing. So the main logic will contain this is cycle present method. So here what I can do is, as I have discussed, so I have to maintain one array where actually the states I can maintain like 0, 1 or 2, and then we have to take one queue to maintain like which one we have to visit after what, right, in a BFS manner. So I have to define this queue and the array. So the like array I have maintained as node status array. Okay, and I have initialized it with the size of the graph's node, and then I have defined a queue. Okay, now initially what I can do is we can add the starting vertex in the queue. Okay, that will be 0, and I can make that entry in the like status array as 1. That means it is visited. Now while this queue is not empty, uh, while this queue is not empty, what we have to do is we have to like dequeue the element. So I can define that as like node, and then I have to like pull that one. Okay, and whatever node value I'll get, for that purpose the status array I have to mark it as 2, because this node will be processed, right? Means once it is out of the queue, that means there is no use of it, means that node is processed. Now I have to fetch the adjacent nodes for the like dequeued node, right? So suppose 0 node is dequeued now, so we have to find like what are the adjacent node for 0. So how we can find that is I will get the like linked list for that, because adjacency list is actually maintaining a linked list. So how to get that is for graph dot al, in that graph, in the nodes index position, we will get the integer. If you see here, right? So we will get all the adjacent nodes for that particular node, and now we will traverse to all these nodes and add them in the queue. So integer I have to traverse. Then this condition you have to check, as I mentioned that time, for the loop part. So if this node status array of that I position is already 1, then we have to return true, means loop is there, right? Or else what we can check is if this node status of I equal to 0, then we can include them in the queue, means they are not visited yet. So queue dot add I, and we will mark their status as visited. So their status will be equal to visited. And when we will completely run this one, so we will get the result as if it is not contain any cycle, means nothing to return from here, and at the end we will just return false. So now let's run this program. So if you run this program, yes, it is saying the graph contains cycle, that is true. So now what we can do is maybe we can change few lines here and check like if it is again containing cycle or not. So if I change this line 3 to 4 and 4 to 3, this connection if we closed, then if we check, so this time it is saying it is false, means there is no cycle detected. So that's it about this finding a cycle in a undirected graph. Thanks for watching.